now we have to design a DFA accepting exact length of 1 or 3. In this case, if you will try to find out the minimum length string, that is 1, accordingly we will have only 2 states, 1 plus 1, that is 2. So here this is the first exception where we cannot simply say that by finding the length of the minimum string we can find out the number of states. Here the number of states are going to increase, and here we have to apply our logic also. So for one bit, if we have to accept all the strings of length 1, then this is your initial state. On this state, when you will input 0 or 1, you will reach to the final state q1. So this DFA is accepting all the strings of length 1, but if you introduce transition to this state and you reach to q2, and if you don't make it as the final state, so the strings will not be accepted, then we will introduce a third state, that is q3. Again on this state you are going to introduce 0 and 1. So for this state we have made the transition for 0 and 1. Similarly for q1 we have made the transition for 0 and 1, and for the third state also we have made the transition for 0 and 1. If you make this as the final state, it will accept all the strings of length 3. So 0 is accepted, 1 is accepted. Coming to 3-bit combinations, 0 0 0, 0 0 1, and similarly all these combinations including 1 1 1 are accepted. So this DFA is accepting all the strings of length 1 or 3, but we are left with the transition of this state 0 and 1. So again, as I have explained you in the earlier examples, so we will introduce a dead state for this state and will reach to q4, which is a non-final state. We also call it as a dead state, where we will make the transition for this state 0 and 1, and whenever it tries to increase the length of the string from more than 3, it will never accept it. So this is the desired question. Thank you.